Here's another question. Posing. If we have two things, why do we have two things? Why are there two ways to do the same thing? Why do we even have comprehension syntax in Python? In Python 2.0, they added list comprehensions. List comprehensions go all the way back to Python 2.0. They've been around forever. In Python 2.7 and 3.0, list comprehensions were extended to not the list in the set, but the dictionary in the set. There is, of course, no tuple comprehension, except for what you can create yourself with the PEP 448 unpacking. And then in Python 3.6, with the async and await syntax added, these were further extended to include asynchronous comprehensions. We won't talk much about asynchronous comprehensions. But just to remind you, if we have a list, we could build another list by iterating over the first list like this. And here we're taking each value in the list, and we're getting the square of each value. Or we could do this in comprehension syntax on one line. And one interesting thing about this comprehension syntax is it doesn't actually require that we write any new code. It just requires that we rearrange the pieces of code that we would have written in the for loop. You can see this is really just a rearranging of those pieces. Why on earth is there comprehension syntax? Because I already told you I am not a believer in doing everything on one line unless you're just trying to impress somebody who has just told you a story about how they are a pilot and they're also, they can also captain a boat and they were the quarterback of their high school football team. And you're like, well, you should see how much Python I can write in one line of code. Then maybe the bar will turn in your favor and they'll turn away from the, newscaster, handsome football player in college, pilot who's also the captain of a boat. Because jamming everything onto one line is not itself valuable, it really raises an important question. Why do we have the comprehension syntax? What is this even used for? How do we justify this? Now I want to show you, just like we did for the function versus lambda, things which are and are not possible in these syntaxes. Here, I've changed y's very slightly. I've added a seed element. And I could do that for my comprehension here and just say put one element at the beginning. And I've added a criteria, predicate, that indicates whether an element is added to y's. So if the elements are even, they're added. And so here we go. And here we can do the same thing in the comprehension. So we can add things like these kind of predicates. And we can do all sorts of things here. We could say if x is greater than 0, we square it. Otherwise, we cube it. And I can put that into the comprehension as well. If x is greater than 0, else we cube it. And again, I'll show you that the comprehension is really just a restating of the for loop code, just moving the pieces around and removing the append. There you go. There you go. Really basically the same thing. Now, obviously, it would be a little bit more writing if I wrote this clause like if x greater than 0, do one of these and the other. But you can think that that transformation is actually external to this one transformation we're showing. We can do nested comprehensions as well. And you can see here we have a nested structure and we're iterating over one layer and the other layer. And when you look at this code, you can see, yeah, it's pretty clear. The comprehension is really just reorganizing lines to jam everything onto one line. And here's the thing. When I write comprehensions, I often write them spanning multiple lines, so I haven't even gotten the benefit of jamming everything into one line. Let me show you what a comprehension cannot do, however. You cannot try except in a comprehension. The comprehension, like that lambda, needs the target of the comprehension to be an expression. And you can't use any of the statement grammar here. So you can't try except, you can't define a function, you can't class, except all the ways you can do it. The try except is actually a pretty hard limit. It used to be the case back in the day that when you were doing a get adder on an object, if an exception was raised, it would say, oh, the attribute doesn't exist, if that was any kind of exception. Whereas these days, the actual exception type percolates up. But back in the day, if you wanted to, within the comprehension syntax, actually do a try except, one of the things you do is in one line, create a custom type using type, add a get adder to it, do a has adder on that to see if the attribute's there, and then let the exception kind of hit the get adder and say the thing's not there, and then you know if there's an exception. You couldn't capture what the type of the exception was. Those contortions are no longer possible. And like the lambda, you can find contortions to jam things in that you're not supposed to, but for the most part, there are it's not really worth it trying to do those contortions. And there are hard limits like the try except. Unless you write a separate function that you can't, within the comprehension, within the bytecode that it itself runs, do something like try except. But there's also one more thing, very subtle, that you can't do. Let us take a look at this structure. I start with a seed value of 1. I go through each element of x's, and I square that element, and I add it to the previous value. And so instead of this being each of these values squared, 16, 9, 4, 1, and so on, it now has this statefulness, 1, 17, 26, 30, 31. And one thing about this is this kind of stateful structure is very hard to understand because you have to kind of step through it, and you often have to step through it in your mind. And when you step through in your mind, you're often building a little table saying loop 1, this is the state, loop 2, this is the state, loop 3, this is the state, loop 4, this is the state. And you're basically recapitulating a Python interpreter in your brain, except it's slower and more error-prone and buggier. This kind of code is very hard to understand. Sometimes it's necessary. It's really the only way to solve the problem with some sort of stateful structure that you're looping over. For the most part, we try to find ways to avoid it because it can be so difficult for somebody to understand. It's just really eyeball what's going on. But fundamentally, what is relevant to us is you cannot do this within a comprehension. Within a comprehension, you cannot refer to the structure you're building as you're building it because the name binding doesn't happen until the comprehension has been constructed. So you can't refer to this thing as you're building, which means the comprehension is strictly limited to only being able to produce new structures which do not look at the previous steps of the direction. So you can't do things like scans and folds with comprehension syntax. This is why, for example, you'll see that if you have like a default dictionary and you're using the default dictionary to categorize something, so you're saying, for X in some data, do default dictionary of, or maybe you have, default dictionary of x.field.add X, like this. And here this default dictionary is like a default dictionary of sets, and this is your, categorization. Like that. Well, here, that's fine. But you cannot do this in the comprehension because you notice this thing is referring to the structure as it's being built, and you just can't do that in comprehension. So you can't do these kind of categorization tasks in the comprehension syntax. Now, that's not strictly true. There are ways to do this in the comprehension syntax, making use of something that we'll see in a moment, the assignment expression. It's just extraordinarily unpleasant and extraordinarily ugly. Obviously, you could do something like this. You could have some external state. And you could say, oh, you know what I'm going to do? I'm going to take the last element of the external state, and I'm going to add it to this. And then I'm going to append this to my external state. And because I know append returns none, I'm going to return what the internal thing here was. You could do this, but honestly, you shouldn't. And it's going to be pretty easy to spot if somebody's doing something weird like this. Or what you can do is, and you can see here, this should be x's here. Or, and let's uncomment this. Or one other thing you could do is and this is even less pleasant, you could do something like this. You could say, grab the last value, and the last value is equal to, you could try and look into the comprehension's global scope and try and get out whatever the last value is if it wasn't set, like this. But again, this is very obvious. Somebody's going to be able to see that something weird is happening, and you're really pushing the limits. And basically, other than having this external state or just the last value, you're somewhat limited. You can't actually see the structure itself. You can't mutate the structure itself. So for example, on loop 14, you can't go back to the result that came to you from loop 3, which you can easily do here. You could easily do something like say, oh, if some criteria is met, change element 4 of this thing to something else. That is going to be basically impossible to do in the comprehension. Why does this matter? It matters because the choice of what you use is a way for you to communicate things to people reading your code. We've seen this before. Tuple versus list versus set versus frozen set versus dictionary. We saw it in the previous session. It's what you're communicating to the people reading your code so they can understand what your intentionality is. If you have a bunch of code and it looks like this, the intentionality is absolutely clear. This line is data. This line is creating a list. And notice that when people are going to read this code, they're going to skim over it. And what they're going to see is this. When they skim over this, are they going to be able to understand what this code does? Sure. Create some data, create a new list, create a new list. And when they want to dive a little bit deeper into this, let's see what they're going to see. So they're like, okay, now I want to go back to this code and see what this does. Create a new list. Create a new list with what? Oh, with some values squared. Create a new list with what value squared? The values in x's. Create a new list with what? Some value incremented. What value incremented? Oh, the values from ys. Under what criteria? Well, if they're even. And you can see the comprehension syntax is about taking that for loop, which obscures certain things like what are you actually trying to accomplish? What are the steps involved? And it regularizes and structures that so you can easily skim this code. You can look at this code and you can say, I know what this line does. I don't have to look into the nitty-gritty details. Whereas, anytime you're reading your code and you see a for loop, you have to understand how did that for loop affect the rest of this program. And if you see a ys equals empty list here, you're going to be searching for that and say, okay, how did it build this thing? And maybe it's doing some other useful work at the same time, and you'll have to tease that apart. Comprehension makes for easy skimming of code that conveys a very clear idea. All this line does is it builds a list. And this is why I don't care if it's all on one line or not, because even if it's not all on one line, it still accomplishes its goal of saying you can skip all of the stuff in the middle as long as you get that this line builds a list, move on with your life, come back to it, and go deeper into how it's building that list if you need to. But you don't necessarily, at first glance, need to really, really know all of the small details. You can skim this and get a better sense of what the rest of the code is doing. This is why, for example, when I see people take code that looks like this for underscore in range 3, you do something and they turn it into a comprehension to put this all on one line. First, I already put it on one line. There's really no benefit. Mine is one character shorter. And second, this line is a lie. This line is misleading. This line tells me I want to create a list. And I want to create a list with the results of the print function. And I want to create it with the list of the function, the results of the print function, but I didn't want to do anything with the list because I didn't even assign it to anything. Definitely, this is even worse. This is saying I wanted to create a list and I wanted the side effect of creating a list. This is the worst. I wanted to create a list full of things and I wanted to do something with that list, except it's just going to be a bunch of nuns. There's nothing interesting in here. This code says I want to do something 3 times. What did you really mean? Did you mean I want to create some data, or did you mean I want to do something repetitively? Some people, when they learn comprehension syntax, they just go full bore and they use it everywhere. It is a very bad idea because it is so misleading. If you mean in that line of code, create some data, use comprehension syntax, especially since you can say to somebody, I'm creating some data, and I'm creating it in a way that doesn't do anything weird, like define a function or have a context manager or try except. I'm defining in a way where it's just a single expression where it cannot refer to the thing that's being built as it's building that you can easily skim. No tricks up my sleeve, skim over this line, no big deal, come back to it when you need to see the details. Whereas when you do the for loop, you're saying, I need something stateful, so maybe you should be a little bit careful about reading this, or I need to do something n number of times, I need to perform an action. You can think that the statement expression dichotomy in Python allows you to distinguish between statements, which mean to a user, do something, perform an action, change the world, and expressions, which mean compute something, give a result, but don't necessarily do anything stateful.